Okay, so no problem. I will share any one animated video. So it will take only hardly 2 to 3 minutes. So after completing the animated video, I will go to the second problem. Okay. So if you want to continue the animated session, please remind me. I hope the screen is visible to everyone. So it is a CD content from the author book called Ramesh Babu. Okay, so here you can able to see all kind of syllabus. So far now we have discussed about the points, lines, planes, and projection of solids. So and we are discussing about section of solids right now. So in this content you will be having a 13 example of animated videos. Okay, so these 13 examples are a different kind of solids and a different kind of conditions. Okay, so I'm going to play any one. So you can see this profile. So this one is a vertical plane and this one is a horizontal plane. And there is a problem for this condition. So I'm going to read out the problem first. A hexagonal prism, side of base 45 mm and axis 75 mm long, rests with its base on HP. Okay, such that one of its rectangular faces is parallel to VP. Okay, rest with base on HP. So the base should be exactly on the HP and such that one of its rectangular face is parallel to VP. So this one will be called it as a rectangular face. This particular surface will be called it as a rectangular face. So you can see it here. So this particular edge is parallel to VP. So this one is VP. This particular surface is VP. So a component edge is parallel to VP. So we have satisfied the condition. And after that, a section plane. So you can have that particular word, a section plane. So if you receive a problem like this, then you can fix this problem belongs to third unit, section of solids. Okay, a section plane perpendicular to HP and parallel to VP. Okay, cuts the prism at a distance of 15 mm from its axis. So a section plane is perpendicular to VP. That means it should have a 90-degree angle with horizontal plane, and also it should be parallel to VP. That means it should parallel to this VP. Then it will cut the prism at a distance of 15 mm from its axis. So the center point of this hexagonal surface will be the axis point. So the cutting plane should 15 mm far away from the axis. So we have to draw the top and sectional front view. So here the condition like true shape is not required. So you can able to understand how to draw a sectional top view or else sectional front view. Okay, so I'm going to play this video right now. So now you can able to see the sectional plane. So this one is the sectional cutting line. So I'm going to remove the particular solid. After removing that, you can able to have the front view in the vertical plane and the top view in the horizontal plane. Okay, so after rotating the horizontal plane in 90-degree clockwise direction, you can able to see this. here we are having only vertical cutting plane. Okay, that means we are having vertical section line. So the true shape is available in the front view itself. So there is no need of creating the true shape with the separate diagram. So this one is the true shape. Okay, so this particular rectangular profile with the hatching. So this one will be called as hatching. So here you can read the word hatching. I already told you have to create this line with the distance of 2 mm and with an angle of 45 degree. So this particular profile will be called as hatching. So you have to hatch the cutting surfaces. Okay, is it clear? So similar to this, we'll be having a 13 examples. That's all about my condition. So இப்போ சொல்லுங்க உங்களுக்கு இது draw பண்ணணுமா வேண்டாமா? சரி திருப்பி play பண்ணணுமா வேண்டாமா? If there is no response, I will move on to my second problem. யாரா சொல்ல வந்தீங்க? ஓகே, யாருக்காவது திருப்பி ப்ளே பண்ணணும்னா சொல்லுங்கப்பா, இல்லைன்னா நான் ப்ராப்ளம் போயிடுவேன். அதுக்கப்புறம் நீங்கள் கேட்காதீங்க இது. Okay, thank you. We will close this session. Okay, so our second problem. So you can see the ending of this first problem. Is there any doubt regarding square prism? Do you have any doubts? Okay, so the second problem is a square pyramid. Okay, a square pyramid of base 30 mm and axis 60 mm. Long is standing on HP. That means the base is standing on HP. Okay, standing on HP means standing on HP with its base. Okay, so the base is standing on HP. So the bottom profile is touching the HP and base edges equally inclined to VP. So if you receive a command like this, base edges equally inclined to VP, then you should not create a normal rectangle, so sorry, normal square. So you should not create your diagram like this. So when compared with the reference line, all the edges should have a common angle. So if it is X and Y, okay, since it is X and Y, you should not create your rectangle like this, because if you are creating a square like this, then we can call these edges and these edges is parallel to reference line, and this particular edge and this particular edge is perpendicular. So what is our condition? It should have a equal angle. That means you have to create your square with an angle of 45 degree. So you have to create your square like this. We are creating any one edge with an angle of 45 degree, then the opposite edge is also at an angle of 45. Okay, so that is what our condition. You have to create this square with an angle of 45 degree, and it is cut by a section plane. So you are having the particular word is cut by a section plane. So this problem is belongs to third unit. Okay, so perpendicular to VP and inclined at 30 degree to HP. So your cutting plane is inclined at 30 degree to HP, and also you will be having the condition for the particular point. So what is this? Bisecting the axis. So the condition is bisecting the axis. So I will show you the condition while creating the problem. And we have to draw the sectional top view, and also we have to draw the true shape of the section. In some problems, they will only ask for you have to create the sectional top view or else front view. So true shape அப்படிங்கிறது கேட்டா மட்டும் draw பண்ணுங்க. In some problem, there will not be any condition whether you have to create a sectional top view or else front view. அந்த மாதிரி வந்துச்சுன்னா you have to create the front view, top view and also true shape. அது இல்லாம draw the front view and top view ன்னு மட்டும் கேட்டா அதோட நிப்பாட்டிக்கங்க. Please don't create true shape. எதுவுமே கேட்கலைன்னா true shape draw பண்ணுங்க. Okay. So if the upper portion is removed, so it is clearly mentioned that we have to remove the upper portion. So in our previous problem, they didn't mention about whether we have to remove the upper portion or lower portion, because this one is the cutting edge, right? So this one is the cutting edge, and we are not having any condition whether we have to remove the upper portion or else lower portion. So we have removed the upper portion. So there is no condition you can remove the upper portion. Okay, so in this second problem, they have clearly mentioned about we have to remove the upper portion. Okay, and you have to create your reference line. And please remember one thing, you have to draw the true shape. So please draw this diagram at the center of your page. Okay, so you have to draw this diagram at the center of your drawing sheet. Okay, so you have to create your square with an angle of 45 degree. So the square is inclined at an angle with the VP. So you have to create your square in the top view position with an angle of 45 degree. So here it is not mentioned whether we have to create with an angle of 45, but they have clearly mentioned that it is equally inclined. Okay, it is equally inclined. If it is equally inclined, compulsorily you have to create with an angle of 45 degree. Okay, then you can project your sorry, before that you have to mark the notations. Since it is a square pyramid, so it is a square pyramid, it is not a prism. So you have to join the opposite edges with the center point. So this one is our center point. Okay, so you have to join all the corners with the center point. Okay, and you can name each and every corner with a notation called P, Q, or S, or else you can do it as A, B, C, D, or else 1, 2, 3, 4. So it is your choice. So there is no problem. Okay, but the cutting edges should have a different notation. Okay, so after doing this, you can project all the points towards the front view, and also you have to project the center point also. Since the height of this pyramid is 60, you have to create your axis with a height of 60 mm. Okay, then you can connect all the corners towards the apex point. So this one will be called as apex point, and these particular lines will be called as slant edges. So please don't forget the words because you'll be having conditions like slant edges or else apex in the problem. So the top edge will be called as apex, and the slanting edges will be called as slant edge. Okay, so you'll be having a 3 lines. So here also you should create the line because you can able to see this Q to O line. Okay, so you can create your notations with this, and after creating this, you have to create your sectional plane. So the sectional plane is inclined at 30 degree to HP. So it is actually, it is not T, it is TO. So 30 degree to HP. Okay, so bisecting the axis, what is meant by that? Bisecting the axis. So bisecting means you have to pick your center point exactly at the center of your axis. Okay, so the axis height is 60 mm. So you have to pick a point exactly at the center. So that means the center point should have a 30 mm distance from the reference line. If it is this particular dimension is 50, then you have to create this dimension with 25 mm. So that is what called bisecting. Bisecting means center of the axis. So this one will be called as axis, right? This one is a axis. Okay, so you have to pick a point exactly at the center. Okay, if it is 70 mm, then you have to pick a point exactly at 35 mm above the reference line. Okay, so then you can create your sectional plane with an angle of 30 degree. So it is 30 degree to HP. So you can create your sectional plane with an angle of 30 degree like this. Okay, so after doing that, please remember one thing, then only you have to highlight your front view. After creating the sectional plane, then you have to remove one particular portion. So please don't erase the remaining portion. You should not erase the remaining portion. So please leave as it is. Okay, so you have already created this profile with 2H pencil. Okay, so you don't have to remove this particular portion. That means you don't have to erase the particular portion. Okay, so as per our problem condition, we have to remove the upper portion. So please don't highlight this triangle. Okay, so then you have to highlight the bottom portion. Okay, so this particular line is visible, so you have to highlight this particular line also. And after doing this, you have to identify what are all the edges, cutting edges are available. So it is not this one. So here we are having a cutting edge. So this cutting edge is available exactly at O dash and P dash. Okay, so this particular cutting edge is available exactly at this line. Okay, so you have to project this cutting point towards O to P. So it is available at O dash and P dash. So you have to project this cutting point up to O to P line. So this one is called O to P, right? This particular line is O to P. So P and O. So you have to project this cutting point up to O to P. So you can make a note of this. Then after doing that, here we are having a cutting point. So it will look like a single cutting point, but in this vertical line, normally this vertical line will be called as O dash Q dash of S dash. That means it is available at O dash to Q dash and also O dash to S dash. So it is not a single cutting point. Actually, it is a two cutting points. So this one can be named it as 1 dash and this one can be named it as 2 dash of with a different notation. So before that, mark the point for 3 dash. So this particular cutting edge can be marked as 3 dash. So after that only you have to mark this as 4 dash because you will be projecting this cutting point towards top view and it will be available at O dash of S dash. So you should not directly project this center line. So there is a different procedure. Okay, so there is a different procedure available for marking the particular center cutting pins. So center line la varra cutting points ni direct project panna koodadu. So you can project the rest of cutting edges. That means you can project this 3 dash up to the required position. That means this 3 dash is available at O dash and also R dash. So you can project this 3 dash up to O to R line. So you'll be having another one more cutting edge exactly at this place. Okay, so you have to project this cutting point towards the outermost edges. Okay, so I will show you with the diagram. So 1 dash is projected up to O to P. That one has been marked as 1. And after that, you have to project the 3 dash point. So that can be marked as 3. So we have 2 cutting points. And this particular cutting point should be projected with a different procedure. Okay, so I'm going to mention the procedure. First, initially, you have to project this center point, okay, this cutting point up to the slant edge. Any one slant edge. You can choose either O dash of P dash or else you can choose either O dash of R dash. So you have to project up to the slant edge. So in some problems, you will not find the slant edge. So in that condition, you have to create the slant edge again. So there is a different procedure for that. I will tell you the procedure again. You have to project the cutting point exactly at the axis up to slant edge. Then you have to project this particular point. So now you got another one more cutting point. So this one, you have to project this point up to the center line. That means the horizontal line of O2P. Okay, you have to project up to O2P. Then you'll be having another one more point at this place. Now you have to measure the distance of O with this new point. So you have to measure this distance with the compass. Okay, you have to measure this horizontal distance. Then you have to create two arcs like this. Okay, you have to create a, you have to place the needle of your compass exactly at point O. Okay, then you have to create an arc from this distance up to the vertical line and also this vertical line. So now you will get the remaining 2 points. Okay, so like this, so you will get a name called 2 at O to Q. Then you will get another one more point at 4. Okay, so now you got all the 4 points. Okay, so now you can connect these 4 points with the dot line called 1 to 2 and 2 to 3 and 3 to 4 and 4 to 1. Okay, 1 to 2, 2 to 3, 3 to 4, 4 to 1. And the center portion of this slant edges has been removed, so you should not highlight these edges with the dot line. So you have to create the section lines in between those profile. So please don't highlight these lines. So it is highlighted in this PPT. So please don't do that. It has been removed. So you should not highlight these lines. Okay. So I'm going to mention. I'm going to say again how to draw this point 2 dash or 4 dash. Okay. So now you got. We have projected point number 1 and also 2, 3. So first of all, you have to project this axis cutting point towards any one slant edge, and at that point you'll be having one more you have created one more corner. Then you have to project this corner towards a horizontal line from O. So we are already having a horizontal line from O, so you'll be getting another one more point. Then you can measure the distance of O to this particular new point. Okay, so after doing that, you can okay, so after doing that, you can create an arc from point O to that means you have to measure this distance with the compass. Then you have to create arc from this point to the vertical line and this point to the another one more vertical line. So you'll be having 2 points. So first one can be called it as 2 and next one can be called it as 4. Now you can connect these 4 points with the dark inclined lines. Then you have to hatch the central places with an angle of 45 degree and with a distance of 2 mm. Is it clear? Any doubts? If you're having any doubts, you can ask me. Based on our condition, we have created the sectional top view. So that means this one will be called as section, or else we can call this as hatching. Okay, so we have created the sectional top view. Then we have to project, we have to create the true shape of the cutting section. So what is the condition for creating the true shape? We have to create the imaginary reference line. Okay, so that reference line should be parallel to this cutting plane. So what is the angle of this cutting plane? It is 30 degree. So you have to create this imaginary reference line with an angle of 30 degree. So it should not touches the component lines. So it should have a some more distance from the apex point. Or else you can create this imaginary reference line at the bottom of this diagram also. So like this. So it is depends upon your condition. So there is no need of creating the reference line only at the above front view. So you can create this true shape on below front view also. Okay. Okay. So after that, what is the procedure? You have to project all the cutting points towards the imaginary reference line with an angle of 90 degree. So 90 degree for this cutting plane. Okay. So in the cutting plane 90 degree இருக்கும். Okay. So you have to project a vertical perpendicular line for this cutting plane from point 1 and from point 2 dash of 4 dash and from point 3 dash. So like this 1 dash is projected and 2 dash of 4 dash is projected and 3 dash is projected. Okay. So after doing that, what is our next procedure? So you can measure the distance between the actual reference line to the particular cutting points. That means you have to measure this distance. Okay, this particular distance should be measured. Then you can create an arc from this imaginary reference line towards this vertical line. So you'll be having a arc. So you'll be having intersection. This one can be called as 1, 1. So it is not 1 dash. So this one can be called as 1, 1. Okay. Similar to that, you can measure the distance between this reference line towards 4 and also this reference line towards 2. Okay. So this particular distance should be measured, and also with that, this particular distance should be measured. Then you can create a 2 arc from this same vertical line. So this one can be called as 4, 1, and this one should be called as 2, 1. So 2, 1 is far away from reference line. So you have to create 2, 1 far away from this imaginary reference line 2. Then you can measure the distance of this 0.3 with this actual reference line. Then you can create arc like this. So after doing that, you can mark the notations 1, 1, 2, 1, 3, 1, and 4, 1. Then you can connect all these 4 points with a dark line. And also you have to create the section, or else it can be called as hatching. Okay, with a 2H pencil, so you have to use only 2H pencil for creating the hatchings. Okay, so the procedure for creating the sectional line is that you have to follow the 2 mm distance, and also the angle for this line should be 45 degree. Okay, so any doubts? Shall I move to the next problem? So we have another 15 more minutes. So I'm going to complete the next problem too. So our next problem is that, and also please mention these things. You should not create this kind of arrowheads because it's highlighted for your understanding. So you can write this top view as sectional top view, and you can write this particular diagram as true shape of the section. So please don't create these kind of arrowheads. ஸோ உங்களுக்கு நான் எக்ஸ்பிளைன் பண்ணுறதுக்காக நான் கிரியேட் பண்ணது. ஸோ அதனால் அதை பண்ண வேண்டாம். Okay. So our next problem is that a cone base 50 mm diameter and axis 65 mm long. Okay. Rest with its base on HP. So the base is on HP. So you have to create the top view with a circle. Then it is cut by a section plane perpendicular to VP. So it is perpendicular to VP, then the section plane is available only on the front view. view. So it is having an angle of 45 degree with a HP. And also with that, it will pass through any one point. So please read out the next procedure. Passing through a point on the axis 35 mm above the base. Okay, so the section plane is passing through the axis with a distance of 35 mm from the base. So here you have to create the sectional top view and you have to create the sectional side view also. So it is different. So far now we have not created the side view. Okay, and you have to create the true shape of the section. So you have to create the three diagrams. So front view is common. So without creating the front view, you can't able to proceed further. So front view is common. So compare front view compare பண்ணாம நீங்க மூணு diagrams create பண்ணணும். So side view is different. Okay, so you can create a reference line with the name of x and y. Then you can create the circle with a diameter of 50 mm. Then you can divide the circle into 8 equal parts and you can name it as 1 2 3 4 5 6 7 8, or else you can name it as a b c d e f g h, or else p q r s t u v w. So it is based upon your own choice. Okay, so here it is marked as a b c d e f g h. Okay, then you have to project all the points towards the front view position. After that, you have to create an axis with a height of 65 mm. Then you have to connect all the points towards the apex point like this. You have to create all the points towards the apex point. But please remember one thing: you should not highlight your front view. Okay, then you can create a point that is 35 mm from the base. So this particular point is 35 mm above from the base. Okay, now you can create your sectional plane with an angle of 45 degree. So here the angle is 45 degree to HP. So you can create your section plane with an angle of 45 degree. Okay, and here there is no mentioning about you have to remove the top portion or else you have to remove the bottom portion. So I am going to remove the top portion. So the bottom portion is fully visible, so you can highlight the bottom portion. So only you have to highlight the outer edges because it is a cone. So this line and this line is created only for dividing the circle. It is not a edge or else it is not a component line. So you don't have to highlight that particular edges. So only you have to highlight this. Okay, so then what is your procedure? What is your next procedure? You have to create the sectional top view. That means you have to project all the cutting points towards the top view. So எங்கெங்கெல்லாம் cutting edges இருக்கு? So here it is the first cutting edge. It is available at O dash and A dash, and here we are having two cutting edges. Okay, so what is the name of this cutting edges? அதை நம்ம கடைசியே பண்ணிக்கலாம். So this particular cutting edge is available exactly at O dash and B dash of H dash. So that only I am saying that here we are having two cutting edges. And this particular place we are having two cutting edges, that is because we are having the rotation C dash of G dash. And here also we are having two cutting edges. And almost it is a one cutting edge because this one is O dash and this one is O dash. So what is the procedure? We have to project all the cutting edges towards the top view. So initially you can project point 1 towards this one can be called as O, the center point can be called as O. So this particular cutting edge can be projected up to O to A because the available as dash and dash. Then you can project this cutting edge towards B to O because you'll be having another one more cutting edge at this place, and also you'll be having another one more cutting edge at this place. So the name of this vertical line is B dash of H dash. So you have to project this point towards H2O and also B2O. And I already told you that you should not project this axis cutting edge directly. So it is a different procedure. So what is a different procedure? So you have created 1, 2 and also 8. So the different procedure is that you have to project this cutting point up to the outermost edge. Okay, then you have to project this point towards the horizontal line from O. So we already have a horizontal line from O. So in some problems like pentagon, you will not be having a horizontal line from the center point. So that means you have to create the horizontal line. So after doing that, you'll be having one more cutting, so that means one more corner at this place. So you can measure this distance with a compass, then you can create an arc like this, and also you can create an arc like this. So you'll be getting another 2 more cutting points at this vertical line. So this one can be called as 3 and this one can be called as 7. Okay, so after doing that, you can project the next cutting edge, that is called this one. It is available as O dash to D dash of F dash. So you can project with a vertical line up to D dash of O. So D of O. So you'll be having a cutting edge at this place and also you'll be having a cutting edge at this place. So it's a 2 cutting edges. So you can mark this this one as 4 and 6. Then the last one. So the last one is available at O dash to E dash. So you can project up to O to E. So you'll be having a point at O to E. That can be called as 5. Okay, so now you've got all the cutting edges. So normally you are having 8 cutting edges. If you are dividing a circle into 8 quadrants, 8 equal quadrants, then you'll be having 8 cutting edges. Okay, since it is a cone, you should not join all the cutting edges with a line. So what is the meaning of that? You have to join all the lines with a circle, that means curve. So it should be done only with your free hand. Okay, you should not use compass or else you should not use pro circle. You should join all the points with your free hand and it should be a perfect circle or else ellipse. So normally it will look like a circle. You're looking from the top view, it will look like a circle. Okay, so it should be done only with your free hand. Then the procedure for creating the sectional top view is that you have to section the cutting profile. That means you have to create the section lines like this. Okay. Then you can create your true shape. So what is the procedure? It's a common procedure. You have to project all the cutting points towards the true shape diagram with a 90-degree line. So that 90-degree should be based on the sectional plane. You have to create it from 1 dash and also you have to create it from 2 dash of 8 dash, then 3 dash of 7 dash, then 4 dash of 6 dash and 5 dash. So what is our next procedure? You have to measure the distance between the reference line towards these points. Okay, so from the reference line towards point number 1 and from the reference line towards point number 8 and point number 2, then from the reference line to point number 7 and point number 3 and the reference line to point number 6 and point number 4, then the reference line to the point number 5. So these particular distance should be measured with your compass, then you can replicate the same dimension exactly at these places. So you'll be having 8 more cutting points at this place. Okay, so please remember one thing. So the cutting point should be marked at the same place. That means if you are measuring the distance from the reference line towards point number 1, then you have to create that particular arc from point number 1, because this one is the vertical line from point number 1. So you have to create only the arc at this place. So after doing that, you can connect all the cutting points with the perfect curve. So it should be done only with your free hand. And also it should be a perfect ellipse. Okay, so we'll be having all the points. So it will be look like a perfect ellipse. Then you have to section this ellipse with a hatching line with a distance of 2 mm and an angle of 45 degree. Okay, so that's all about sectional top view and true shape. And there is a different procedure for creating a side view. So it is totally different. That means you have to create a 45-degree inclined line from your reference line. So the point can be chosen at any place. So like this. So this angle should be 45 degree. Okay. So it is a different thing. This angle should be 45 degree. Then you can project all the points on your previous sectional top view towards this inclined line. That means you have to project this point G, and also you have to project point H and F, and also you have to project A and E, and also B and D, and also C towards this 45-degree inclined line. And also you are having another 8 more points. So 1 and 5, and 8 and 6, 8, 7, 6, okay, then 4, 3, and 2. So you have to project all the points towards this inclined line. And similar to that, after doing that, then you have to project all these new points. So these points can be called as new points. So you can project all these new points towards vertical. Okay. Towards vertical. So after doing that, then you have to project the points from your front view towards this vertical line. Like this. So இந்த மாதிரி நீ எல்லா பாயிண்ட்ஸையும் ப்ரொஜெக்ட் பண்ணணும். ஓகே, நார்மலி இந்த செக்ஷனல் சைட் வியூ மேக்ஸிமம் கேட்கறதுக்கு சான்சஸ் இல்லை. பட் உங்களுக்கு தெரியணும் அப்படிங்கிறதுக்காக தான் இந்த ப்ராப்ளம் அந்த மாதிரி கொண்டு வந்துருக்கு. Okay, so you have to project all the points. So after doing that, you'll be having an intersection for each and every notations. That means point number 1, or else for an example, I'm going to show 45 degree is created, 45 degree inclined line is created. So I'm going to project this particular point number 1 towards this inclined line. Then I am going to project this point with a vertical line. So after doing that, I have to project a point number 1 from our front view towards this point number 1 vertical line. So we'll be having an intersection at this point. Then it can be called as 1 1, or else it is already created with the name of 1 1. So you can dash 1 1 dash, or else 1 double dash. So the side view should be marked with 1 double dash. So please remember one thing. The side view should be marked with double dash. So this particular point can be called as 1 double dash. Similar to that, you have to project point number 2. Then you have to project point number 2 at this place. So you'll be having an intersection. And point number 3, point number 4, and point number 5, point number 6, and point number 7, and point number 8. Everything should be projected. So if you did that, you will be having a circle exactly like this. Then the top portion has been removed. So you can project the outermost edges like this. Okay, you can project the outermost edges like this with a vertical line. Okay, then you can connect this particular edge with this corner, and also you can connect this particular edge, and also you can connect this particular edge. So only this surface is visible. So the remaining top surface should be removed. Okay, so any doubts? Okay, no. You have to submit these two problems within Friday. Okay, so the assignment will be created with our today's class. So you have to submit these two assignments, these two problems within Friday. Okay, so if you're having any doubts, you can ask me, or else you can leave the class.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.